through your career and your writing and your acting, you've inspired so many people to enter the sciences. How do you balance science with science fiction? They're both the same.
I've been discussing time and warping time and time-space with some famous scientists. I'm doing something up in Canada which may sell, they may sell that show called The Truth Is in Our Stars. And I've talked to Michio Kaku and David Suzuki, and I'm going in a couple of weeks to talk to Dr. Stephen Hawking. And I tried to get through his book, A Brief History of Time. It's not brief. And it doesn't have much to do with history. And everybody I've met who is acquainted with the subject, I'm continually asking, look, I hear space-time all the time. No, space-time, it's space-time. That without space, without time, it's time and the space is the time.
Hard to comprehend what it is.
Well, I don't comprehend what it is, so I ask these very important people who are working in the field, what is space-time? And they say, well, the gravitational force takes the photon of light and advances the photon of light. So without space, without time, you got the time that comes. I said, well, wait a minute. If in 13, and I said this to Dr. Kaku, in 13.5 years, he says, no, 13.8 billion years. He corrected me by 0.3 billion years. If that photon, I said to him, if that photon of light at that farthest galaxy takes 13.8 billion years to reach my eye, isn't that time? And he said, yes, but the space-time and the time and the space and the space and the time. And I couldn't understand, my opening sentence to everybody, including, it will be to Dr. Hawking, what is space-time? And I can't, and I know 17 people just raised their hands. I'll tell you about space-time. But it's a concept that I just can't get through my head.
Well, you can understand time, the passage of time.
Are you going to explain to me what space-time is?
Yes. And you can understand the idea that there's space, there's a distance between you and these 6,000 people.
Wow. You said that with a measure of pride, too.
Yeah.
Creation, 6,000 people are in the audience.
But it takes a certain amount of time for you to pass from here all the way over to the other side of the auditorium.
Right, that's space.
That is time going, time going through space.
You see, that's not what they mean at all. That shows me that you have no idea. I mean, so the guy said, one of the gentlemen said, well, there are 3 dimensions, space, length, width, right? And then you have the concept of time. So something happens within that space, you got time. That's the 4th dimension. Yeah. And I said, well, I get that. Something happens within a cube, and you have time, and then you have length and breadth and width. And I get what's the 5th dimension, I said.
That's a fantastic band.
A fantastic band. That was my first thing. So I said, just give me another, because he said there's 11, then he said there's 17, and then I heard lately there's 26 other spaces.
Dimensions,
multiverses. No, wait a minute. So I said, well, just give me one other dimension. I don't care about 16 or 17 or 26. What is the 5th dimension? What is it? Give me another dimension. And the answer is, we can't conceive of that.
You know, right.
So
that doesn't mean it doesn't exist.
Well, it doesn't mean it does exist. You know, so I mean, so I said to Dr. Kaku, he said, it's in the, because he's working on string theory. You know about string theory.
Yeah, and I find that incredibly confusing too.
But we're not talking about the stuff you wrap a package about, Adam. It's vibration of some kind in a string. Okay? So I said, he said, it's like music. I said, well, I understand an orchestra with vibrating instruments. I got that. What do you play? What's your instrument? What do you do? When you get up in the morning, doctor, what do you do? And he says, it's all in my head. I think. I said, well, how do you prove what you're thinking exists? Because it's all theory. He said, well, I've got this very elegant numbers, equation, yeah. Very E-B divided to 7 to 4. It's all in his head. How do you prove a black hole? How do you know those gravitational waves proved the collision of two black holes?
Somehow, eventually, they are able to observe phenomena.
No, they can't observe. It's too far away. It's too theoretical. How do we know what they're saying is true? You know what it really is? It's all science fiction.
So does that make you a skeptic?
No, well, science fiction says this is a story that I'm making up, and there's this thing called wormholes, and that's a science fiction concept. Although these scientists say there are wormholes. How do you know?
The mystery of science fiction is what I'm talking about. Science and science fiction are essentially the same.
Well, they're going through a wormhole to another part of the galaxy. So I mean, it's science fiction, all right? Okay. But we know about wormholes. We know the mathematics of them. We don't know how to make one yet. And plus, they're kind of unstable, and if you go in, they might collapse. So you have to, that's the science fiction part of it. There's a wormhole sitting there allowing people to leave Earth and travel much shorter amounts of time to go to another part of the galaxy.
What's the difference between a black hole and a wormhole?
Yeah. So a black hole, you fall in and you're not coming out ever,
okay.
all right? A wormhole has a lot of the similar physics to a black hole, except it's a portal to another place in the galaxy.
Okay.
And so you can use it, in principle, to travel great distances much faster than if you otherwise sort of took the detour. And in Star Trek, they kind of do that, with their warp drives. They warp space, and they can travel
That's
much...
a wormhole.
Well, at the time they didn't have that vocabulary, and if they did, that's surely what they would have called it.